Good morning, everyone. Today's topic is basic theorems of Boolean algebra. Now, see, to solve the Boolean algebraic equations or expressions, we have different theorems. So, first we will see the basic theorems which we have. So, total eight basic theorems we have. So, one by one, we will discuss all of these. So, first is the properties of 0 and 1. So, total four properties we have of 0 and 1. See, these all properties are for single input. Suppose x we are taking as a single input. So whenever any input, the first property say that whenever any input is added with 0, the output is always same as the input. Like suppose we have x. Now this x can have two possible outcomes. It can be either 0 or either 1. So suppose we are making a truth table to prove this uh, property. So we have made a truth table where 0 will remain 0 only. Fine. One input is 0. And second, we have taken x. X can be either 0 or either 1. So two possible values of x are there. Now see, whenever this x is added with 0, the outcome is always 0. Now see, 0 plus 0 is 0. That is similar to input only, x only. Here also, if x is 1, 1 is added with 0, it always gives 1. That means input only. So we can compile this truth table and we can say that 0 plus x is equal to 0. This is proved using this truth table. Now second property is whenever any input is added with 1, the output is always 1. See, two possible values of x can be there, 0 and 1. Whenever any value of x is added with 1, the outcome is always 1. Either it is 0 or it is 1. So 0 plus 1 always 1. 1 plus 1 is also 1. Hence proved. See, the third property say that whenever any input, either 1 or 0, is multiplied with 0, the output is also 0. So, two possible values of x, 0 and 1. Whenever multiplied with 0, the output is always 0. 0 into 0 is 0 also. 1 into 0 is also 0. So, hence, this property is also proved. Now, the last property of this 0 and 1 is whenever any input is multiplied with 1, the output is always similar to the input. Either the input is 0 or 1, the output will be same as input. Suppose two possible values of x, 0 and 1. If 0 multiplied with 1, the output is also similar to input x only. See, the output is 0. 1 into 0 is 0 only. 1 into 1 is 1 only, which is similar to this x. So we can say 1 dot x is always x. Now the next theorem is idempotence law. This theorem states two equations. First equation is x plus x is always equals to x. And second law states x dot x is always equal to x. Either multiply x with x, it will also give x, and either add x with x, it will also give x only. Now this law can be proved using a truth table. Make a truth table for this. We have taken x, 2x we are using. So if x is 0, or if x is 1. So if we'll add 2x, 0 plus 0 will always give 0, which is similar to x only. And 1 plus 1 is also 1. So we can compile this truth table and we can say that x when added with x is always x only. So using this truth table we have proved this law. Now second law states that x dot x is also equals to 0. Sorry, x. So make a truth table x, two possible values 0 and 1. 0 when multiplied with 0 is always 0, and 1 when multiplied with 1 is always 1. So using this truth table, this equation is also proved. So idempotence law states two equations. This is the first equation and this is the second equation, and using these truth table you can prove these two equations. Now next is involution law. This law states that complement of any number when complemented again gives the same number, or any input's complement when complemented again gives the same number, same input. Fine. So we'll prove this using the truth table. We have taken any input x, two possible values are there, 0 and 1. First we'll find out the complement or not of this x. Fine. So x naught will be 0's value will be complemented as 1 and 1 is complemented as 0. Now again complement this column. x complements complement. So 1 will again turn to 0 and 0 will again turn to 1. Now compare these two columns, first and last column. These are same, x and x complements complement. These two are same. So we can say x complements complement is equals to x, or we can say not x not is equals to x. This law is also known as double inversion law. Fine. So the next basic theorem is complementarity law. Now this law again states two equations. First is x plus x complement is equal to 1, and second is x dot x complement is equals to 0. Again we can prove it using a truth table. Make a truth table for single input, two possible outcomes 0 and 1. We'll do the complement of this x complement, 0's complement is 1, 1's complement is 0. Now what we have to do, x plus x naught. We are finding out the LHS. So x plus x naught will make, so 0 plus 1 is 1 and 1 plus 0 is also 1. So both the possible outcomes of 0, the output is always 1. So we can say that x, any value of x, when added with its complement, it gives 1 only. Now similarly we can prove this statement also, x dot x complement is equal to 0. Again make a truth table for single input, two possible values 0 and 1, find out its complement and find out the LHS, x dot x complement. So x dot x complement is 0 into 1 is 0 and 1 into 0 is also 0. So whenever any input is multiplied with its complement value, the output is always 0. When two input and its complement are added, the value is always 1. When they are multiplied with each other, the value is always 0. So both these laws are proved using the truth table. The next theorem is commutative law. It also states two equations. The first one is x plus y is equal to y plus x. The second one is x dot y is equal to y dot x. Now see, we can write x plus y in this format also, y plus x. Either 1 plus 2 is equal to 1 plus, or we can simply say that 1 plus 2 is equal to 2 plus 1. Simple. Fine. So to prove this law, we again will make a truth table. We have two inputs here, so we make a two input truth table. Two input truth table will have four possible combinations. So we have made four possible combination table. Now first find out the LHS, x plus y. So x plus y, we have written the possible outcomes, and y plus x. Again y plus x, find out the y plus x and write the output. Now compare these two columns. See the values. These two columns are identical to each other. So we can say that using truth table you have proved this law. X plus y is always equals to y plus x. Similarly, x dot y is equal to y dot x. We can say that 3 into 2 is equals to 2 into 3 if we talk about maths. So what we are doing, two input truth table will make four possible outcomes, then find out LHS, then find out RHS. Now compare these two columns. Both are similar, both are identical. That means this proves that x dot y is equal to y dot x. Now the next theorem is associative law. This law also have two statements. This one is the first statement. It states that x plus y plus z within bracket is equal to x plus y within bracket plus z. Fine. So we can prove this using truth table, or we can prove these laws using algebraic way also. So first we'll prove this using truth table. Now see, this is the equation. What we'll do, we'll make a three input truth table. X, y and z are there. So three input truth table will make. Three input truth table means how many possible combinations? 2 to the power 3, that means 8 possible combinations of x, y and z. So make a 8 possible combination truth table for x, y and z. Now first we'll find out LHS, then we'll find out RHS. So for LHS, first we will find out y plus z. Similarly, x plus y also we have find out. Now LHS, complete LHS is x plus y plus z. Find out x plus y plus z. So what we'll do, we'll add this x with y plus z. Similarly, right hand side x plus y plus z. So this is the x plus y, add this x plus y with z. Now these are the two columns. This is LHS, this is RHS. Now compare these two columns. Both are identical to each other. So using this truth table, we have proved that x plus within bracket y plus z is similar to x plus y within bracket plus z. This is similar to associative law in mathematics also. Fine. So next statement is x within bracket y plus z is equal to xy within bracket z. So we are using truth table to prove this law. So again, three input truth table will make 8 possible combinations we have made. Now one by one, first find out the LHS, then find out the RHS. Using this truth table, we have find out the LHS also and RHS also. Now compare these two columns. These two columns are identical to each other. Fine. So we can say that this theorem is also proved. Fine. This theorem is also proved. Now next theorem is distributive law. Distributive law states that x within bracket y plus z is equal to xy plus xz. This theorem you have done in mathematics also. So again, either prove it using truth table or algebraic. So we have made a 3 input truth table, 8 possible combinations. Now first find out the LHS and then find out the RHS, then compare both of them. So we have find out the LHS, similarly find out the RHS. Now compare these two columns. They both are identical, so hence proved. This statement is verified. Now the next next equation of distributive law states that x plus yz is equal to x plus y into x plus z. Now see, either prove it using truth table or algebraic way. We are using this, proving this using algebraic. See what we'll do, we'll take RHS. Fine, so we have taken x plus y dot x plus z. Now what we'll do, we'll multiply each term of this first bracket one by one with each term of other bracket. So first we'll multiply this x, then x with z. Similarly, we'll multiply this y with x, then y with z. So first we'll multiply this x dot x, then x dot z. Similarly, y dot x plus y dot z. So we have got 4 terms now. Now see, x dot x, we have learned in idempotence law that x dot x is always equals to x. See, since x dot x is equal to x, so we can write this term as x. We have written it x. Rest all the terms are same. Now see, first two terms, we can take x as common. So we have taken x as common. What we are left with? We are left with 1 plus z, and two terms are same. Now see, 1 dot z, we have learned in the basic properties of 0 and 1, 1 plus any input always gives 1. So 1 plus z will be equals to 1 only. So we can write 1 plus z is equal to 1. So in place of 1 plus z, we have written 1. Now see, again in properties of 0 and 1, we have learned that any input when multiplied with 1 always give the input itself. X dot 1 will be always equals to x. This is the basic property of 0 and 1. This is the first property we have learned of Boolean algebra. So x dot 1 will be equals to x only, and two terms are again the same. Now see, first two terms, again we can take x as common. We are left with 1 plus z and the same term yz, sorry. Now 1 plus z again can be written as 1. So we can write 1 in place of 1 plus z. Again x dot 1 is equals to x and yz is same here. So we have got x plus yz, which is the LHS. So RHS is equal to LHS, hence proved. So you can prove this equation using either truth table or you can prove it algebraic also. Now the last theorem we have is absorption law. This law also states two equations. The first is x plus xy is equal to x. So we can either prove it using truth table or algebraic way also. So first we'll make truth table. Two inputs we have. So we'll make a 2-input truth table. 4 possible combinations we have made. Now find out the LHS, x plus xy. So first we'll find out xy, then x plus xy. Now see, we have got the LHS and in RHS we have x. Now compare this x with x plus xy. these two columns are identical to each other. Fine. That's why we can say this equation is verified. Fine. Similarly, we can solve it algebraic way also. So what we'll do, we'll take the LHS from here. X plus xy. We have taken the LHS. What we'll do, see, x can be taken as common, so we have taken x as common, but we are left with 1 plus y. 1 plus y is equals to 1 only, so we have written 1 here in place of 1 plus y. So x dot 1, we have x dot 1. X dot 1 is also equals to x only, so we have written x. We have got the RHS, so LHS is equal to RHS, hence proved. See, here we have used both the methods. You can use any of the methods. The last absorption law, second absorption law, and the last in the basic theorems is x plus y is equal to x only. So you can solve it using truth table also. We have algebraic proof for this law. What we'll do, we'll take the LHS x plus y. Now what we'll do, multiply this x with 1 by 1, this with this x also and with y also. First multiply this x with x dot x plus x dot y. Now see, x dot x is equals to x. Fine. Now take this x as common. We have taken x as common. We are left with 1 plus y. Now 1 plus y is equals to 1 and x dot 1 is equals to x. Now this theorem is proved using the algebraic proof. Now this way you can prove these basic theorems. So these were the basic theorems. Tomorrow we'll learn about the De Morgan's theorems, and they are very important. De Morgan theorem is very important. So that's it for today. Thank you.